let's talk about, let's check the past Jamb questions, and let's see how we're going to revise with you. Okay. Now, number 1 says, which of the following alkanes has a straight chain structure? Which of the following alkanes has a straight chain structure? Well, looking at these options, we see that all are from the alkane family. You know, hydrocarbon has, the hydrocarbon is shared into alkane, alkane, alkyne, and all of them gives you the alkanol. But let's see the correct answer there. The correct answer there is, okay, butane do not have a strange structure. Butane has C subscript 4, H subscript 10. Okay? Now, this is the structure of butane. This is the structure of butane. Okay? This is H, this is H, this is H, this is H, 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 and H. This is the structure of butane. So it does not have a straight structure. You can see there's a curve here coming straight, and there's a curve here coming straight. So you see the structure is not straight. They say a straight line, a linear structure. That's a straight line. Now, let's take a look at pentane. So that you give me the answer by us. Let's take a look at pentane. Pentane is C subscript 5, H subscript 12. Okay? This is C, 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 and C. This structure is hydrocarbon. You know, hydrocarbon is the study of hydrogen and carbon. Okay, how they bond together with other elements like sulfur, nitrogen, oxygen. All right? So it's just the study of hydrocarbon compounds, a compound that consists of hydrogen and carbon. Now, if you check, there's a straight structure, 1, 2, 3, 4, 5. Now, in structurizing any hydrocarbon, the carbon is the one sharing the bonds. The carbon is the one sharing the bonds. Okay? That means the carbon is being placed at the middle. Then it shares a bond. Those lines you're seeing are called bonds. Now, let's see this H, 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 and H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if you see, this is a straight structure. That is why the answer becomes B, butane, pentane, sorry. So the answer is B, pentane, because pentane is the only structure that has a straight chain structure of the alkanes. So let's go to the next one, see if we answer it. The next one is, which of the following factors does not affect the rate of chemical reaction? So the following factor does not affect the rate of chemical reaction. Remember, a chemical reaction is a reaction that leads to the chemical transformation of one set of certain substances to another. A chemical reaction is a reaction that leads to a chemical transformation of one set of substances to another. For example, let's say this is hydrogen molecule reacting with oxygen to give us this. I know you'll be confused when I wrote this. This, HOH, is still the same thing as H subscript 2O. This is dihydrogen oxide. Dihydrogen oxide. It's still the same thing as water. Now, if you check, there's a transformation of hydrogen and oxygen to water. Hydrogen is a separate element, reacting with oxygen as a separate element. Okay? Both of them gave us a different element, that is water. Hydrogen is a gas, oxygen is a gas, and both of them gave us a liquid. A liquid. So there's a transformation of this element from a gas phase to a liquid phase. Now, in this water, you cannot tell the amount of hydrogen inside. If I bring a cup of water and I look inside, you can't tell me the amount of hydrogen inside the water. Now, the only thing you can use to see this thing is called a spectrometer. A spectrometer is an instrument used in viewing atoms and molecules in a substance. That's the only thing you can use to see it. But if you check in this structure, like I brought out this illustration, this reaction I brought out, you will see that the reaction is shared into two, the reactants on the left and the product on the right. Now, in this chemical reaction, this thing cannot go back to hydrogen and oxygen by any known chemical processes. It's just like an element, you know. And this thing is called a pure substance. That is because it has a constant composition and a distinct property. Look at this. The two atoms of hydrogen still remain two atoms of hydrogen after the reaction. And then, in essence, the elements proportion remains the same before, during, and after the reaction. Now, they said, which of the following factors does not affect the rate of chemical reaction? Now, the concentration of the reactants talks about the type of reactant. The type of reactant. What kind of reactant is reacting together? Is it a metal? Is it a non-metal, or is it a metalloid? What do I mean? Is it a gas? Is it a solid, or is it a liquid? Okay, what type of metal it is? So the type of metal tells you how fast the reaction might go. Type of metal tells you how fast the reaction might go. So in essence, this concentration of reactants affects the rate of chemical reaction, because the type of reactant, the type of element, the type of compound that is reacting to form another compound tells you how fast this particular reaction can go. The second one says is temperature. Remember, in every chemical reaction, heat is added. So as the heat is being added, that is how the temperature is increasing. So that means temperature also affects a chemical reaction. If you check the presence of a catalyst is any substance that takes part in a chemical reaction and remains the same afterwards. So from the definition, you know that a catalyst takes part in a chemical reaction. That means to say it speeds up the reaction, but it remains the same after the reaction. It does not change. So that means the presence of catalyst affects. Now, if you check the molecular weight of the product, the molecular weight does not affect. Hydrogen here is 2. That is the weight of hydrogen, 2 atoms. It still remains 2. All right? It's not because it's not because the hydrogen is 2, then the oxygen is 1. That does not mean that a compound was not formed. A compound was formed. Bringing these two substances together, you see that they formed a compound. No one was higher than the other. Now, in the ratio, they formed a single product. Every chemical reaction brings about a singular product. So in essence, the molecular weight did not affect the rate of this chemical reaction, because the hydrogen that was 2 atoms was still 2 before the reaction, during the reaction, and still after the reaction. So there was nothing that changed. So the molecular weight of the product is the answer. And that answer is D. D is the answer. That is because the molecular weight of the product does not affect the rate of chemical reaction. So the answer for number 2 question is D. D. Let's go to the next one. The next one says, who proposed the planetary model of atom with electrons orbiting around the nucleus? With electrons orbiting the nucleus. Now, an atom, according to Ernest Rutherford, is defined as a chemical species that consists of the proton and the neutron in the nucleus surrounded by a cloud of electrons. Surrounded by a cloud of electrons. That means to say the electron is at the outermost shell of the atom, in the electron orbit or in the atomic shell. Outside. The electron is outside the atom. Take, for example, the structure of the atom. You know, this is the nucleus of the atom. Now, inside the nucleus, we have the proton and the neutron. And outside, we have the what? Electron. Now, this H plus is still called hydrogen ion or proton. H plus is called hydrogen ion or proton. This H is the neutron, while the H minus or OH minus is called hydroxide ion. Hydroxide ion. This H plus is still called hydronium ion. It's still called hydronium ion. Now, look at this particular structure I drew for you. I said according to Ernest Rutherford, he defined the atom as a chemical species that consists of the proton and the neutrons in the nucleus surrounded by the electron. Now, the proton and the neutron are both called the nucleons because they stay in the same house, which is nucleus. That means to say they exhibit similar characteristics and they are found in the nucleus. That is why they are called the nucleons. 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 That's why they are called the nucleons. Now, they say the first scientist is J.J. Thomson. J.J. Thomson was the person that profounded the electrons. He found out the electrons in 1897. That was the first particle to break out from the atom. Okay? That was the first particle to break out from the atom. Apart from the discovery of the ions by Michael Faraday in 1834, the first person to break the atom was J.J. Thomson, Joseph J. Thomson, Sir Joseph J. Thomson. But it was first theorized by Ernest Rutherford. First talked about, that's what I mean, by Ernest Rutherford. Now, J.J. Thomson was the first to break the atom and bring out the electron. Okay, he just profounded the electron. He did not tell us where the electron was placed in the atom. Now, Ernest Rutherford discovered the proton. Discovered the proton in 1926. Ernest Rutherford discovered the proton in 1926. He did not tell us where the proton, he told us where the proton was situated because he said that the proton was in the nucleus. It's found in the nucleus. Now, Niels Bohr gave us a Bohr's model theory. Bohr's model atomic theory, that's what they call it. Bohr model atomic theory. He told us that the electrons is at the outermost shell of the atom that is constantly in motion. That is constantly in motion. That means to say the electron is surrounded, forms a cloud around the nucleus that is called the electron cloud. And that thing is called the electron cloud. The process where the electron forms a cloud around the nucleus is called the electron cloud. So Niels Bohr told us that this electron is found at the outermost shell of the atom, or the electron orbit. Why it's called electron orbit? Because that is where the electron shows its strength. The electron is the lightest subatomic particle that has the highest kinetic energy. The proton is 1,084 times heavier than the electron and 1,000,000 times electrically charged than the electron. The proton is 1,084 times heavier than the electron and 1,000,000 times more electric charge than the electron. Now, if you check their charges, from their charges you can calculate. This is the charge of a proton. Proton, while this is electron. No, 19. This is the charge of an electron, and this is the charge of a proton. Okay, so Niels Bohr gave us the model that the electrons are orbiting around the nucleus. And with doing that, they form an electron cloud, which means they form a cloud around the nucleus. Because as they're going around, okay, as they're going around, they are scrubbing the edges of the atom. And as they're scrubbing, particles are falling, and those particles are called the lattice of electron. Okay, it's called the lattice of electron. So when the electron cloud is formed, then the electron captures the nucleus, changing the proton to a neutron. Changing the proton to a neutron. So with this simple explanation, you agree with me that the answer is C, Niels Bohr. Let's go to the next one. What type of reaction is involved in the formation of alkanols from alkanes? Alkanols from alkanes. Now, the type of reaction that is formed in the production of alkanols from alkanes. Okay? Now, substitution reaction is simply to substitute elements. It's still called displacement reaction. Okay, when elements are displaced, okay, the less reactive element is being displaced at the product level. The less reactive element is being displaced at the product level. Now, addition reaction is a reaction that adds. Addition reaction is a reaction that adds to the compounds to form a new compound. A reaction that adds to the compound together. It brings the compounds together to form a new reaction. Okay, now they say alkanols from alkanes. Alkanols has a molecular formula of CnH2n plus 1 OH. While alkanes has a molecular formula of CnH2n. This is organic chemistry, like I told you to put your head in. Now, if you check this alkanol and the alkanes, all right? Now, the difference between both of them is the OH structure. The OH structure. Now, when they say what type of reaction is involved in the formation of alkanols from alkanes, addition reaction. Now, when you remove this OH and add it to alkane, it becomes an addition. When you remove this OH and add it to alkane, it becomes an addition. That means to say the reaction was added from alkanol to what? Alkane. So it's addition reaction. B. The next one is, which separation technique is used to separate different pigments in a mixture based on their affinity for a stationary phase and a mobile phase? Filtration, they say A, filtration. Filtration is used to separate solids from liquids. Filtration is used to separate solids from liquids. For example, I have rice and water. Just take, for example, I have rice and water. Okay? Or I have, okay, those local people that do pap. When they do the pap, they pour it on a white cloth. And as they are filtering, the water is going down, and the precipitates are on the cloth. Or I take rice and water, for example. I put a normal rice, right? I put a normal cloth, and I pour the rice on the cloth. You see the water will go down. Water will leave the cloth, and the rice will remain. So filtration is used in separating solids from liquids from solids, or solid from liquid. Distillation is used to separate suspended impurities in liquids. Suspended impurities in liquids. Suspended impurities in liquids. Distillation. Or sometimes it's used to separate miscible liquids. Miscible liquids are liquids that can mix. All right, either colloidal particles from liquids. Colloidal particles are suspended particles in a liquid or in gases. These are distillation. While chromatography is used to separate different pigments. Pigments, for example, colors. Okay, it's used to separate different colors. Decantation is used to separate solids from liquids too, but it is not an accurate way of separation. It's not an accurate way of separation, because water, or because the liquid will still, the solid will still retain the liquid. Not all the liquid will leave the solid in decantation, because the solid substance goes to the end, goes to the end of the container, and the water floats on top. So, looking at chromatography, chromatography is used to separate pigments, colors. In essence, in the separation of chromatography, films are formed when they are separated. Okay? Films are formed when they are separated. When you snap, in those days when we used to snap pictures, the pictures, first of all, appear in a film, in a negative film. Then that's when we are going to wash the film for it to come out as a normal picture. That process is called chromatography. So the answer for question 5 is chromatography. Let's go to the next. What is the Faraday's constant? What's the Faraday's constant? Now, the Faraday's constant is calculated in coulomb per mole. Faraday's constant is calculated in coulomb per mole. Mole there is not a constant. The mole there is the amount of substance. Measurement of the amount of substance. Meter per second, which is the B, is acceleration. It is not a constant. The D, meter per second, is velocity. Velocity is not a constant. It's a process. Acceleration is still a process. Okay? Amount of a mole is calculating the mass of that product. While the Faraday's constant is calculated in coulombs per mole, like I said. So the answer is C. That is 6,485 coulombs per mole. The next one is identify the reducing agent in the following reaction. I want to give you a simple way. Okay, in every reducing agent, a reducing agent is any substance that gains electron in a reaction. Any substance that gains electron in a reaction. Any substance that gains electron in a reaction. While oxidizing agent is any substance that loses electron. But some people will say loses oxygen and gains oxygen. Fine. But in the main definition, it's called loses electron and gains electron. So reduction is when they lose electron, and oxidation is when they gain electron. Now, if you check the reaction, they say it is zinc reacting with copper sulfide or copper tetraozosulfate 6 gives us zinc sulfide or zinc tetraozosulfate 6 and copper. Every reducing reaction or every reaction that talks about reducing agent there is an addition to the first element in the reaction. There's an addition to the first element in the reaction. While in every oxidizing reaction, there's a subtraction from the first element in the reaction. So in other words, the first element gains electrons. In the reaction, the first element gains electrons. It's a very simple thing. You just, in every reaction, the first element reacts with the last element, while the second element reacts with the first element. The first element reacts with the second element, while the second element reacts with the first element. That means it gives us A plus B equals to AB plus CD gives us A will react with D, AD plus BC. That's the reaction. AB plus CD gives us AD plus BC. Now, in this context, we have only A, there's no B. But that means but. And here we have A, no B, but we have C and D. This is A, this is C, and this is D. Now, they said the A must react with D in the reduction reaction. The A must react with D. But if there is a B, the B will react with C. So that means, since the A will react with D, then the answer will be zinc sulfide. The answer will be zinc. That will be the answer, zinc. Because the first element is the one that gains the electrons. The first element is the one that gains the electrons in reducing agent. While in oxidizing agent, the first element is the one that loses the electrons. So the answer is D, zinc. Let's go to the next question. They said, what is the solubility product constant used for? Solubility product constant is being abbreviated to KSP. K there represents the constant. S is for solubility, and P is for the product. Now, when they say solubility, they're talking about solutes that can dissolve in a solvent. Okay, the solubility talks about solutes that can dissolve in a solvent. Now, let's first of all know what a solubility product constant is. A solubility product constant is the equilibrium constant. A solubility product constant is the equilibrium constant for the dissolution of solid substances. For the dissolution of solid substances into an aqueous solution. Solubility product constant is the equilibrium constant for the dissolution of solid substances into an aqueous solution. When they say aqueous solution is simply a solution where the solvent is water. That means to say, it talks about a solute dissolving in water. A solute dissolving in water. And it is determined by temperature. It is determined by temperature. Now, for example, I put salt into water. Okay? It's going to give me a salt solution. And that salt solution is still called aqueous solution. That solution is an aqueous solution. The type of solution is called aqueous solution. The name of the solution is called salt solution. Take note. The type and name are not the same thing. Okay? Type of solution is an aqueous solution. An aqueous solution, or is still called a saturated solution. Saturated means the solute, the dissociated, dissolved, dissoluted inside the solvent completely. Completely. So, from the definition, you know that when they say solubility product constant, it talks about when the solvent dissolves in the solute completely to form one product, equilibrium, an equal product. I put salt into water, it gave me one product. Like the solution is being defined as the combination of two or more substances to form a single product. So both of them gave me a single product. In other words, it gave me a homogeneous mixture. A saturated solution is still a homogeneous mixture, where the solute dissolves in the solvent completely to form a single product. So in this solubility constant, they are telling us that the solute dissolved completely. So in essence, the measurement of this thing is a constant. It is a law, it's a fact, that everything I put dissolved completely. I don't need to measure which one dissolved and which one did not dissolve. So when they say a constant is a phenomenon. A constant is a normal thing, is a fact. Like you're telling me night and day is a constant. It does not change. Night and day. Time is a constant. Time does not change. 12 o'clock today is still 12 o'clock tomorrow. Because when you calculate the time, 12 p.m. from now to 12 p.m. tomorrow is still 24 hours. So it is a constant. It does not change. So let's see the options. Option 1A says to determine the concentration of a solute in a saturated solution. B, to calculate a solubility of a solute in a given solvent. C, to measure the total mass of a solute that can dissolve in a solvent. And D, to compare the solubilities of different solutes in the same solvent. Now, when you check B, B says to calculate solubility of a solute in a given solvent. You don't need to calculate it because you already know it. What you know, you don't need to calculate. If they tell you 1 plus 2, 1 plus 1, you do not need to calculate 1 plus 1. You don't need to calculate it because it is a constant. You already know it's 2. When they say to measure the total mass, that means B and C are the same thing. Because when you're measuring total mass, you're still calculating the solubility. It's just a different way to confuse you. B and C are the same thing. Then D said to compare. You do not compare. You don't compare. Because they say the solution dissolved completely. So there's no comparison. If I put salt and sugar, both of them dissolve the same completely. No difference. So I don't need to calculate or to compare which one dissolves more, better than the other. Why the A tells us to determine the concentration of a solute in a saturated solution. So the answer is A, because I know the concentrated solution that dissolves, the solute that dissolves. A solute is a substance that dissolves in a solvent completely. A solute is a substance that dissolves in a solvent completely, while a solvent is a substance that a solute dissolves in completely. While a solvent is a substance that a solute dissolves in completely. So the answer is A. It is used to determine the concentration of a solute in a saturated solution. It's used for us to know it. We know it, that this is the amount that dissolved. So let's go. The next one is number 9. What is the principal ore of iron from which iron is extracted? Okay? The principal ore. Ore is simply a region or an area where metals have been extracted. Have been extracted from where metals is found and they have been extracted. That is ore. Then when the metals are extracted and modified for use, it's called metallurgy. When the metals are extracted and modified for use, it's called metallurgy. I repeat, ore, an ore, metal ore, iron ore, aluminum ore, any ore, is defined as a region or an area where metals is found. When I say ore of iron, means an area where iron is found. And that area is called hematite. That area is called hematite. Calcite is where calcium is found. Borazite is where boron is found. Magnetite is where magnesium is found. Hematite is where iron is found. I repeat, an ore is an area where metals are found. Where metals are found and extracted. Now, when these metals are extracted and modified for use, it's called metallurgy. It's called metallurgy. Take note. Let's go to the next one. The next one, it says, how many pi bonds are there in an alkane with 6 carbon atoms? Pi bonds are there in 6 bonds. Pi bond is a bond formed. Pi bond is a bond formed by the overlap of p orbitals. Pi bond is a bond formed by the overlap of p orbitals. Overlap of p orbitals in an adjacent manner. In an adjacent manner. Pi bond is a bond formed by the overlap of the p orbitals in an adjacent manner. Any bond that is formed by the p orbitals, the p orbital has a dumbbell shape. The p orbitals, they have a dumbbell shape. When you go to your atomic structure, you know how to arrange these configurations, electronic configurations. The p orbital has a dumbbell, that's the shape of the p orbital. It has a dumbbell shape. A pi bond is formed by the p orbitals, okay, by the overlapping. How many overlapping, okay, carbon atoms? Okay, if you check the overlapping, every pi bond, every carbon atom bond together is being bonded by 2. It's being bonded by 2 bonds. Okay, each bond is bonded by 2 carbon. Each bond is bonded by 2 carbon. So the p orbitals being bonding together is 6. They say 6 atoms. So 6 atoms minus the number of bonds of 1 bond. 2 will give us 4. The p orbital, every single bond, like I said, one bond, one straight line is called a bond that connects 2 carbon. One bond connects 2 carbon. So the 6 atoms must have to minus those 2 carbons to give us 4. So the answer is 4. Number 10 is 4. Let's go to the next one. The next one is, according to the kinetic theory of gases, the pressure exerted by a gas is due to the weight of the gas particles. The weight of the gas particles is not done by pressure. The weight of the gas particle is not done by pressure. Because if I put 1 kilogram of gas inside a container, inside a cylinder, the space or the region or the radius of which those particles will acquire is determined by the number of particles in that gas, and it's called molecular radius. Molecular radius is the molecule that is displayed in a solution. The number of molecules displayed in a solution determines the space that they're going to occupy. So the weight of a gas is not determined by pressure. Okay? The attractive forces between the gas particles. Gas particles have no attractive force. They have no cohesive force. That's one of their characteristics. The gas particles have no cohesive force, so they are not attracted. So B cannot be the answer. A too cannot be the answer. C says the collision of gas particles with the container walls. The vibration of gas particles. Gas particles do not vibrate because they escape vigorously. They don't vibrate because they escape vigorously. Okay, they diffuse vigorously. Okay, when for example, I open a gas cylinder, you see them going out, they are scattered. They are random motion. They go around. Now, the collision of gas particles in the walls of a container, when I put the gas in the container, because of that, the particles expand to fill this container. Why? Because the molecules exhibit more kinetic energy. All right? Now, when the container is being, let's say I put a gas in a cylinder, the gas is compressed because the gas cannot escape. Now, as it's escaping, the cylinder is distorting their movement. The cylinder is distorting their movement. So in essence, they are being compressed in a container. So the only way a gas can be compressed is when it's being put in a container. Now, the collision of gas particles with the container walls. Now, every single kinetic energy leads to pressure. Every kinetic energy leads to pressure. Now, because the particles of matter have kinetic energy, they are always in motion. That's the kinetic theory. They are always in motion. Now, when these gas particles, okay, because gas particles have the highest kinetic energy, so they're always moving. They're always in random motion. So as they're moving, they're hitting the walls of their container and coming back to collide. So when they collide themselves, more pressure is being exerted on them. It's like when you hit somebody. Okay, when you hit somebody, more pressure is exerted on you. Either you hit the person and fall, or you hit the person and shift back. In essence, your movement at that time is faster than when you're coming to meet the person. That same pressure can still make you to stop your movement. That same pressure can still make you to enhance your movement. So in this process, the gas particles enhances their movement due to pressure. When they hit the walls of the container, they come back and hit themselves. As they hit themselves, they spread out more. It's like in a boiling water. Okay, the molecules that is exhibited that you call bubbles, okay, hit themselves. When they hit themselves, they break because enough pressure is added upon them. So they hit themselves and break. When they break, gas comes out. In those bubbles that you see that exhibit on the surface of the water, it is vaporized inside, not water. Because when it breaks, evaporation occurs. So the collision of gas particles with the container walls, when they hit themselves, more pressure is exerted on the walls, on the particles of the gas. So the correct answer is C. Correct answer is C. Let's go to the next one. The next one says, what is the empirical formula of a compound containing 40.00 carbon, 6.67 hydrogen, and 53.33% oxygen by mass? Now, this is empirical formula. Empirical formula is the formula that shows you the simplest form of a molecular formula. That's the shortest definition. It shows the simplest form of a molecular formula. Now, in solving empirical formula, what you use is the molar masses of the substances. Now, the molar mass is not given here. That is why I said you should be comfortable with your periodic table. Comfortable with your periodic table, the atomic numbers, their molar masses. You know, atomic numbers is sometimes mostly times 2 of the atomic number, except in some cases like chlorine, cobalt, you know, lead, and so on and so forth. But mostly it is times 2. Now, you need to work with the molar masses for you to get the empirical formula of a compound. Okay? For you to get the empirical formula of a compound. Number one rule of solving empirical formula is, number one, if you have watched the previous videos on atom mole formula and equation, you will see the rules on how to solve empirical formula. But I'll still give you here because of this revision. Number one says change the percentage to grams. They said oxygen by mass. Mass is grams. SI for mass is kilograms. So anything that has grams inside is mass. Number one says change the percentage to grams. Take note. Number two says divide these masses, these percentages, or these molar masses by their molar mass. These numbers you had, this percentage that you changed, divide them by their molar masses. Number three says the answer you get, divide it by the smallest answer you have gotten. When you finish measuring all the elements by their molar masses, you get the smallest answer. Use it and divide them again. Number four says the answer you get becomes your subscript. Becomes a subscript of the element. A subscript is the number written at the base of an element that quantifies the number of atoms in that element. That's a subscript. A subscript is the number at the base of an element that quantifies the number of atoms in that element. If you check on the answers, you will see that small numbers are written at the base of the element. Like the first one, you say CH subscript 2O. That 2 there is not CH2O. It's called CH subscript 2. It's called a subscript. That's what they call a subscript. Now take note, if the answer you get is a decimal, you convert. You convert the answer to a whole number. Now let's go. In this solution, let's look at the solution. Solution of this empirical formula. They said hydrogen is how many? Let's look, they said empirical formula, carbon. Carbon is 40.00%. Changing 40 of carbon to mass, changing 40 to mass, still maintain that same 40 in the mass. 40.00. When you change from percentage to grams or percentage to mass in this empirical formula, maintain that same number. There's no conversion, just maintain the same number. So in essence, 40.00% of carbon is still 40 grams. It's still 40. All right? Hydrogen is 6.67%. It's still 6.67. Oxygen is 53.33%. That is O. Is still 53.33%. Still maintain the number. Don't convert it to anything. I just gave you the rules, but still maintain the number. Now, looking at this, the second law says divide by their molar masses. What is the molar mass of carbon? Carbon has an atomic number of 6. That means the molar mass, like I said, is mostly times 2. That means the molar mass will be what? 12. So, molar masses. Molar masses. Carbon is 12. Hydrogen is 1. And oxygen is 16. These are the molar masses. Carbon is 12. Hydrogen is 1. And oxygen is 16. Hydrogen, everything about hydrogen is 1. All right? Everything about hydrogen is 1. Molar mass 1. Atomic number 1. Everything is 1 of hydrogen. Now, oxygen has an atomic number of 8. So times 2 gives us the mass number, which is what? 16. Now you have gotten this. Now they say divide this by their molar masses. Divide this by their molar masses. Now, carbon, 40. If I divide by the molar mass, I'm going to use the molar mass of carbon, which is 12. So 40 divided by 12 will give me what? 40 divided by 12 will give me 40 divided by 12 will give me 3.3. 40 divided by 12 will give me 3.3. Oxygen. Okay, hydrogen next. Hydrogen is 6.67 divided by 1 will still give me 6.67. I am dividing them by their molar masses. I am dividing them by their molar masses. I am dividing them by their molar masses. Now the next one is oxygen. Oxygen is 53.33 divided by 16. 53.33 divided by 16. So, looking at oxygen, like I said, we have done hydrogen. Hydrogen is 6.67 over 1, which is equal to 6.67. All right? Anything divided by 1 in mathematics is 1. All right? Now, oxygen is 53.33 divided by 16. All right? 53.33 divided by 16 gives us 3.33. 3.33. That means it's 3.3. It still says now 3.33. It says now 3.33. Now the rule says, pick the smallest answer and divide all again by it. Now the smallest answer here, we have two answers that are the same. So we pick one. Pick the smallest answer and divide it by it again. Let me start again from the beginning. We said, what is the empirical formula of a compound containing 40.00%, that's still 40% carbon, 6.67% hydrogen, and 53.33% oxygen by mass? I said the first thing you would do is convert the percentage to mass. Now, when you're converting the percentage to mass, you do not, I repeat, you do not do any conversion. The number you get, work with that number. That means to say 40% is still 40 grams. 6.67% is still 6.67 grams. While 53.33% is still 53.33 grams. Now, they say the second one says divide by their molar masses. You need to be conversant with your atomic numbers. You need to be conversant with your atomic number. Atomic number is the number of protons in an element. And that is how they use in arranging the periodic table. So the periodic table is arranged. The elements are arranged in the periodic table according to the atomic numbers. So if you see oxygen as 8 in the periodic table, that means the atomic number of oxygen is 8. Number of protons in oxygen is 8. Now their mass numbers is basically times 2 of the atomic numbers in most cases, except otherwise, except some vital cases. Where you have like chlorine as 35.5 because it's an isotope. Now, carbon has an atomic number of 12, a mass number of 12, because the atomic number is 6. 6 times 2 is 12. Hydrogen has an atomic number of 1. I said everything about hydrogen is 1. And oxygen has an atomic number of 16, because oxygen has an atomic number of 8. So 8 times 2 becomes 16. 8 times 2 becomes 16. Now, divide by their molar masses. Carbon is 40 grams, divided by the molar mass, which is 12. It gave us 3.33. Hydrogen is 6.67, divided by the molar mass, which is 1. It gave us 6.67. Oxygen is 53.33 divided by 16, which is the molar mass of oxygen, equals to 3.33. Now, they see the next step. The next step says, pick the smallest answer and divide all through by it. The smallest answer and divide all through by it. Now, the smallest answer here, we have two numbers that are smallest, that are the same. So we use 1 and divide them by it. We use 1 and divide the answer by it. So carbon here becomes 3.33 divided by 3.33. That is the smallest. It's going to give us 1. Hydrogen is 6.67 divided by 3.33. 6.67 divided by 3.33 is going to give us 2. That's wonderful. It's going to give us 2. While oxygen is 3.33 divided by 3.33. It gives us 1. Because the smallest, we are dividing them by the smallest. So now, they say the coefficient you get, the numbers you get, the answers you get, becomes their subscript. All right? So the subscript of carbon is 1. So it's 1. The subscript of hydrogen is 2. So it's 2. And the subscript of oxygen is 1. So it's 1. This is the empirical formula of this compound. This is the empirical formula of this compound. CH subscript 2O. So the correct answer is A. CH subscript 2O. Let's go to the next one. Next one says, what is the product of the electrolysis of aqueous sodium chloride using inert electrode? Okay, the topic is electrolysis. You need to know the topics when you're doing something. This is electrolysis. Now, they said electrolysis of aqueous sodium chloride. Aqueous sodium chloride. That means to say the sodium chloride is dissolved into water. If you remember, I talked about aqueous solution. I said an aqueous solution is a solution where the solvent is water. That means the sodium chloride was being put into water. Okay, sodium chloride is simply common salt. Common salt. Sodium chloride is common salt. All right? So the sodium chloride is common salt. When salt is being dissolved in water, that's what it means. Electrolysis is just simply the flow of electrons. Electro means electrons, while lysis means flow. The flow of electrons, movement of electrons. All right? That's just a simple way of electrolysis, according to Michael Faraday. So the electrolysis of aqueous sodium chloride, that means the movement of electrons of salt when dissolved in water. That's what it means. The movement of electrons of salt when dissolved in water. Now, sodium basically has a positive charge, while chlorine has a negative charge. Now, when any metal that passes through electrolysis donates or produces hydrogen gas. Now, the sodium is categorized as the cathode, while the chlorine is the anode. Why? Because every metal is electropositive. Every metal is a type of ion called cations. Every metal donates proton, is electropositive, while every non-metal receives electron. Every non-metal is electronegative, so they receive, they don't donate. All right? So when the metals passes through electrolysis, every metal donates hydrogen, produces hydrogen at the cathode. They produce hydrogen at the donating site. In essence, they donate hydrogen. They donate hydrogen. While the non-metal accepts, the non-metal becomes the anode. The non-metal remains the same because they do not donate. So there's no process they pass through. Why the non-metal remains the same because they what? They accept. It's like I have $500, for example, and I'm giving $10 to somebody. It is me that is passing through the process because the money I have is going to be reduced, while the person, the money is going to be what? Added. So the person is not changing. His amount is not changing. The amount he has in his bank is not changing, it's only increasing. While my own is changing because it is what? Reducing. So the metals donates hydrogen during electrolysis, while the non-metals remains the same to accept hydrogen during electrolysis. So the correct answer is A. That's the correct answer. Let's go to the next one. The next one says, which of the following is an example of an endothermic reaction? Endothermic reaction, endo means to absorb, inside. So endothermic reaction is a reaction that absorbs heat. It's a reaction that absorbs heat. While exo is a reaction that releases heat. Now they say burning of methane in the presence of oxygen. Burning releases heat. It does not accept. Now, first of all, the endothermic and the exothermic quantifies the heat content of a system. That is called enthalpy. Enthalpy passes through two types of reaction: endothermic process and exothermic process. Enthalpy is the heat content of a system. How do I know the heat content of a system? Is when I measure the heat that is being absorbed and the one that is being what? Released. The endothermic process and the exothermic process. Endothermic process is a process that absorbs, whereby a system absorbs heat. While exothermic process is where the system releases heat. Take note. So the endothermic reaction is a reaction where heat is being absorbed. Heat is needed to break the molecules. Where heat is needed to break the molecules. Now, when they say burning of methane in the presence of oxygen, burning releases heat. It does not absorb. When you're burning, heat is released. Therefore, energy is being what? Released. The chemical energy that has been gotten is being what? Wasted. It's being released. So it's not the answer. Formation of table salt from sodium and chlorine. Formation of table salt from sodium and chlorine. Heat is released when compounds are formed. Because, they need high level of heat to form a compound. So as they are doing, heat is being what? Released. Right? The next one say combustion. Combustion is still talking about burning. So heat is being released. Then they say decomposition of hydrogen peroxide. For something to be decomposed, heat is added to decompose that thing. Hydrogen peroxide into water and oxygen. So for something to decompose, heat is needed to decompose that thing. Therefore, the heat must be absorbed for decomposition to occur. So the correct answer is C, decomposition of hydrogen peroxide into water and oxygen. Let's go to the next one. The next one says 15. What is the name of the process by which ammonia is produced on an industrial scale? Ammoniation, nitrification, nitrogenation, and Jamb process. And the irrigation is about nitrogen. Nitrification is about nitric acid. Ammoniation is the decomposition of ammonia when an ammonia is decomposed, right? Now, Jamb process is the process that is used to form ammonia from nitrogen and hydrogen. Jamb process is a process that is used for the formulation or for the combination of nitrogen and hydrogen to form ammonia. So from the definition, you already know the answer is called a Jamb process. Number 16 says, what happens to the position of equilibrium if a reverse reaction is subjected to a decrease in temperature? What happens to the position of equilibrium if a reverse reaction is subjected to the decrease in temperature? What happens to it? Now, equilibrium means both equality. That's equilibrium. Equilibrium means equality. Equilibrium means equality. So they say what happens to the position of equilibrium if a reverse reaction is subjected to a decrease in temperature. Now when they say reverse reaction, that means to say the reaction is reversed. The reaction went back to where it started from. That's what it means. The reaction went back to where it started from. So a reverse reaction is a reaction in which the product is reversed. The conversion of the reactant to product. The product is reversed to the reactant. Where the product is reversed to the reactant. That's the reverse reaction. The product is reversed to the reactant. In that context, the position of equilibrium shifts to left. It shifts to left. Because the left talks about the products, the reactants, while the right talks about the products. The left talks about the reactants, while the right talks about the products. So the equilibrium will shift to the left. So the answer remains equilibrium, because if the position of equilibrium remains unchanged, that means there's no reverse reaction. If the reaction stops, then there's no reverse reaction. If the position of equilibrium shifts to the right, that means the right talks about the product. Remember, every chemical reaction has two sides. Every chemical reaction has two sides. The left is the reactant, while the right is the product. So the equilibrium shifts to the left. So the next answer, so the correct answer is B, shifts to left. So the next one is alkynes readily undergo addition reaction with the following. I told you what addition reaction is. Okay? When something is added to alkynes. Alkynes has the molecular formula of CN. Alkynes has the molecular formula of CnH2n minus 2. CnH2n minus 2. So adding O, that means the thing is converting to alcohol. So the correct answer is B. Is A, sorry. It's because alkynes undergo addition reaction with which of the following? Undergo addition reaction with oxygen. So the correct answer is A. The next one says, what type of chemical combination involves the transfer of electrons from one atom to another, resulting in the formation of positively charged ions? what type of reaction of chemical combination involves the transfer of electrons from one atom to another, resulting in the formation of oppositely charged bodies. Take, for example, oppositely charged body, you say sodium, chlorine. Sodium is positive, chlorine is negative. It gives us sodium chloride. These are oppositely charged ions, oppositely charged bodies, oppositely charged elements. Now, the type of bonding tells us the type of compound. The types of bonding tells us the types of compound. Now, a covalent bonding is a bond that exists between atoms and molecules. A covalent bond is a bond that exists between atoms and molecules. And you know that atoms and molecules are electrically neutral. Atoms and molecules are electrically neutral. They are neutral electrically. Neutral. So it is not oppositely charged ions. They are like terms. Their charges are negative. They are both negatively charged. So they are not oppositely charged. The metallic bonding is a bond that exists between metals and metal. Between metal and metal. So metals, we know, are positively charged bodies. So they are not oppositively charged bodies or oppositively charged ions. Hydrogen bonding is a bond that exists between hydrogen and non-metals. Hydrogen bond is a bond that exists between hydrogen and non-metals. Now, the hydrogen is negative already, and the non-metals are still what? Negative. While ionic bond is a bond that exists between metals and non-metals. In essence, it exists between oppositely charged ions. For example, I gave you sodium as a metal and chlorine as a non-metal. So therefore, the correct answer is A, ionic bonding. Because from the ionic bonding, they form ionic compound. The bonding tells us the type of compound it's going to form. So the ionic bonding forms ionic compound. Covalent bonding forms covalent compound. Metallic bonding forms metallic compound. Hydrogen bonding forms hydrogen bond compounds. So the correct answer is A, ionic bonding. Go to the next one. They say, which organic compound is responsible for the characteristic aroma of fruits? Which ionic compound is responsible for the characteristic aroma of fruits? I don't need to explain much. Ester is a sweet aroma smell compound. Ester is defined as a sweet aroma smell organic compound. So ester has aroma. Okay, it is ester that gives aroma to fruits. The name of that compound is called ester. Ester. It has a fine aroma. That's the compound that has a fine aroma. So the correct answer is C. Let's go to the next one. Next one says, what is the main source of carbon monoxide in urban areas? That's pollution. What's the main source of carbon dioxide in urban areas? Urban areas. Industrial processes, yes, is one, but when I say urban areas, that's it, but it's not everywhere. There are some places that are kept for industrial processes. Not everywhere they keep for industrial processes. Volcanic eruptions come once a while. All right? It's the main source of carbon monoxide. Volcanic eruption come once a while. Forest fires. Yeah? It comes once a while too. You burn them once a while. But let's see vehicle emissions. Everywhere in urban area, there are cars, there are vehicles. And those smoke that comes out from their exhaust pipe is carbon monoxide. Everywhere there are cars. So those smoke that comes out is carbon monoxide. So the main source of carbon monoxide in urban areas is vehicle emission. So the correct answer is A,